Hello, welcome to the video presentation for the project of Group 3D. We were tasked to program a remote-controlled car with integrated driver assistance features. These features include collision detection, lane assist, and autonomous parking. On top of that, an expansion of choice should be made. In our case, two expansions have been made. To replace the remote provided in the box and to concise all the mentioned features into one central place, we decided to build an Android application. Our second expansion is an autopilot, where the user has to fill in its current location and its destination. After that, the car will drive autonomously to the desired location. Let's first take a look at the Android app. First, a Bluetooth connection is established between the brick and the smartphone, after which the user is greeted with a couple of different driving options. The app continuously sends an array of 5 bytes to the brick. Different kinds of bytes have different purposes. For example, when driving forward using remote control, the first byte will tell the brick it has to use remote control. The second one determines if the car goes forward or backward. The third one sends a steering angle, based on the tilt of the phone. And the fourth one determines the speed of the car, switching between normal mode and turbo mode. The fifth byte is only used in the autopilot function, and because of this, it will be 0 most of the time. Due to a hardware limitation, the brick is only able to respond to a limited number of byte arrays per second. This is why you'll see some stuttering in the videos showing the remote control. Let's now take a look at lane assist. As shown in the video, the car will detect a black marked line using the color sensor. If the sensor value reaches a certain threshold, it will detect it as a color black, and it will take the necessary action. The car will autonomously turn and return the wheel to the original position, so the user can take control again. The same principle is used in collision detection, only now an infrared sensor gets used. Once the sensor detects a value that is too low, it will stop the car. If it senses that the object in front of the car is dangerously close, it will even go backwards, neglecting any forward input of the driver to ensure the safety.
Okay.
Next up is autonomous parking. The car will search out a viable parking space without the need of any user input. It uses the gyro sensor to keep a straight line and uses the ultrasonic sensor to measure the distance between the car and the other cars on the side. Once a possible parking spot is localized, it drives forward to see if there is enough space to complete the parking operation. Notice how the car will skip the first gap because it sees that there isn't enough parking space. After a suitable spot is found, the car will perform a smooth S-curve and park in a parallel fashion. The smoothness of the measurements and the smoothness of the movement is ensured by using multi-threading. As a last point, we will take a look at our second expansion, the autopilot. The user fills in his current position and his desired location. This info will be put in a matrix and the optimal route will be calculated. After the calculation, the motors of the car will be steered accordingly to drive the car to its desired location. This marks the end of the video presentation. If you hear this, it means that unfortunately our demo has failed. Nevertheless, we hope that we have given you some insight on the possibilities of our car and our expansions. We would like to thank you for your attention and feel free to ask any more questions.